Hey, it's John here, and this is 4Clojure problem 120, sum of square of digits, where I write a function that takes a collection of integers as an argument, and then we'll return the count of how many elements are smaller than the sum of their squared component digits. Okay, so what I want to do with this one is not turn the number into a string and then into characters and then back those characters back into their integers and all that. We'll just do this in a math kind of way. So I want to make a function that turns a number into a sequence of digits. Okay, so we'll call it digitize, and it's going to take some number n. And we'll do a loop recur here. So we'll start with our number, and then we'll have our return value, which will be a list of the digits. Okay, so the first thing we do is we check to see that our n isn't too small. So if n is less than 1, we'll return our return value. Otherwise, we'll recur. Okay, so now we need to divide our number by 10 to get to the next digit. So we're going to do quotient n, and our divisor is 10. And the reason we don't do a divide here is because we don't want to end up with rational numbers. Fractions, basically. We just want to get the numeric, the integer value of result of dividing. So the quotient there is the function we want. And then to build up our list, we will conj onto the return value the remainder of n and 10. Alright, so let's try that out. So we have our function. So let's try digitize 543021. Let's see what we get. Okay, we get 543021. So we have a return this number into a sequence of digits. So that is what we want. Okay, so now let's, the next thing to do is make a function, we'll just call it SOS for sum of squares. It's going to take some value in, and we are just going to, well, it's going to take a sequence of numbers. We're going to map, we're going to map a function which squares those numbers, and then we're going to reduce that list with plus so that we get the sum of the squares. So now if we do SOS on that, let's evaluate that. Now we can try that out, and there we go, 55. What if we do 101, then that should give us what, 2? Throw in a 3, and that should give us 11. Okay, so that's all working. So now let's go ahead and solve our problem. So we're going to make our function, I'll call it SOSD, sum of square of digits, SOSOD, and we will take in some sequence, and then let's make a let binding, and this will be let digitize equal this function definition, so we need to take it from defin to fin, and then we want to bring in our SOS function into this let binding. So there we go, we have it there, and let's give it a name. Okay, so now what we can do is we can map the sum of squares of digitize on our sequence. Let's make this a defin so we can test it out easier. Okay, so that is defined. Okay, so we'll do SOD and then some sequence. 1, 2, 3. There we go. Okay, it says 1, 4, 9. Simple enough. 2, 1, 5. Okay, so 5 would be 1 squared plus 5 squared would be 26. 2 squared plus 1 squared is 5. 3 squared plus 2 squared would be 13. Okay, so this whole thing is working. We're getting the sum of squares for each input number. And what we could do is we could do a zip map on that so that we get, let's see, map that, and we'll do a zip map on this thing with the sequence. So now we have a key value pair. (32) goes to 13, 21 goes to 5, 26, 15 goes to 26. Okay, so now we have a key value pair. So we have the number coming in and the sum of the square of its digits as the value for that key. And since now that we have that, we can filter that and filter this, and we say our function is going to be with a key value for each, and then we want to say that the key is less than the value. So that gives us only one of those 15 is less than the value. And let's try out there. Test range 10. Okay, if we do that, then we see 1, 2, 3, 4, 5, 6, 7, 8 matches there. So that looks right. So now we just need to add in another function, count, on all this, and we have our answer. 8. All right, great. Let's stick it in the site and see what we get. Def is bad. Where did we def? Right here. I can't do that. Let's try again. Okay, we got it right. Thank you for watching.